Electric circuit. In an electric circuit, the flow of charges conducts electric current, and the force existing between these charges is known as force of electricity. It is universal that electric force is a form of non-contact force. Electric change is nothing but the movements of charge in a body. There are basically two types of electric charges, positive and negative, respectively. In an electric circuit, an electric current is present, and this electric current is the flow of these charges in their respective directions based on the magnitude of the charges. As we know, like charges repel, and unlike charges attract, the two positive or negative charges repel, one positive or negative and one negative or positive charge attracts. The charge present in a bulb. In a bulb, the current always flows from high potential to low potential. The high potential is the positive terminal, and the low potential is the negative terminal. According to the law of conservation of energy, energy is neither destroyed nor created, but can be transformed from one form to another. The electric bulb is one such object that works under this law. In an electric bulb, the electric energy is converted as light energy. There arises a force during this conduction of charges. The two terminals of the bulb are conducted to the tungsten filament. When an electric current is passed between the terminals, the thin tungsten filament is heated up by the electrons that flow in such a way that the bulb begins to glow. This process happens at a fast rate. The argon gas present inside the bulb prevents the thin filament from breaking and overheating. The charges in a bulb move in such a way, creating electric force in them. The electric charges present in the bulb move so as to conduct electric current and also electric force. Standing hair. The common phenomenon of standing hair is due to the electrostatic force. The standing hair is normally an experiment to prove the presence of electric force, and due to the electric current. This experiment was conducted by Van de Graaff generator. Van de Graaff generator picks up static electricity of high voltage by transferring charges using a conveyor belt that is synthetic, and this goes on continuously. These charges are transferred and then accumulate in a hollow metal globe. Positive charges, when transferred, get repelled to each other, making one hair stand. Lightning. Lightning occurs during a powerful electrical charge discharge. Thunderstorms are caused by small electrically charged particles when water molecules are heated and cooled, moving up and down against each other. In clouds, there goes on a process where the charges take two separate parts and arranges themselves accordingly, where one part will be negative and the other will be positive. So based on this separation, the particles on the ground gets arranged oppositely compared to the lower part of the ground. Imbalance occurs when such a process happens, so electric current is passed between the charges, and they flow in the direction of fewer particles of the same charge. This very occurrence results in a lightning bolt. This lightning sometimes carries positive or negative charges. In the beginning, the lightning becomes invisible, but when the electric discharge is so powerful, their lightning arc occurs, which then becomes visible. Lightning sometimes occurs in a different color, and this is due to atmospheric humidity, temperature, and air pollution too. Since lightning is so powerful, there are several ways to extract electricity from it. But these are only theoretical ideas and require massive equipment to conduct this experiment. Current electricity. Whenever there is an electric current, there will be an electric field, and then follows the electric force. In a conducting wire, there is an electric current because of the electric field presence, and this electric field exerts a push to the electrons to move along. Different charges attract each other, and the force existing between charged bodies is known as an electric force. The interaction between the charges that are electrically charged is called electric current. The direction of the force that exerts on a positive test charge affects the direction of the electric field. The flow of charged particles in any conductive body produces an electric current when high voltage is provided. The electric force is nothing but the force existing between the charged bodies. Glass rod and silk. In this experiment, a glass rod is rubbed with a cloth. The charged particles are transferred from the cloth to the glass rod. Simply when the glass is brought near another one, it does not move. When the rubbed glass is brought again, the other rod deflects in the direction of the charged particles. For example, when the glass is positively charged, and another one has a charge of the same polarity, they repel, but they attract each other if they have different charges. This occurs because of the electric force in action. Balloon and paper cuts. Taking two balloons and bringing them close to paper cuts does not carry any difference or any effect. Now when the balloons are rubbed together, charges get transferred onto each other. The main reason for such occurrence is that the charged bodies have some force existing between them. When the balloons are rubbed against each other, electrons get transferred from one balloon to another. Now the charges are equally placed, but there is also an imbalance. Since the balloons are charged and brought to a paper cut, it slowly sticks the balloon. The electric force is any main reason for this experiment to be proved. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.